So how precisely does the mechanism of recursion work in Java?
Well, importantly, notice that when we run main over here, right, where we have our fib function, which all it will do is call fib, and our IDE just counts that as a recursive call. Technically, it is recursion, but it's not a properly formed recursive function because it doesn't have an end state, right? Fib will call fib, which will call fib, which will call fib ad infinitum. And you'd think that it would go on forever, except if we run it, we get an exception. Oh, this is really big output, right? Says, let's see. It says, hey, JetBrains, IntelliJ IDE Community Edition, exception at stack is in thread main java.lang.stack overflow exception, or stack overflow error, not exception, error, at all these calls, right? And why the reason is there's so many lines that do this is that it's saying that basically fib called fib called fib called fib called fib called fib until we got a stack overflow exception. So what does that mean? What stack overflowed here, right? Why does it have a name of a popular website? So the answer, of course, that it came is that, inspection infinite recursion options. So it figured out that I have an infinite recursion function there. Don't you love modern IDEs? They're fantastic. So let's go ahead and take a look at the slides.
All right, so the way Java works is that it maintains a runtime stack. That's a special kind of stack. You've got the heap and you've got the stack. The heap is where we build all our objects. The stack is basically our current workspace. And basically anytime you enter a method, you get an activation frame. It contains method arguments, your local variables, and how to get back to whatever called you. Whenever a method is called, whether or not it's recursive, we push a new activation frame onto the runtime stack. So basically, if you have method main, which calls method A, which calls method B, B will have the return address of how to get back to the A function, and A will have the return address of main so that it can get back, right?
So what it looks like is something like this with our length function, length of ace, right? The string will be ace, and then it will contain the return address of main, which called it. And then that will call length CE, right? It will be 1 plus the length of CE, which will be 2, but we don't know that yet. So we know that our parameter was CE, and we have the return address of who called us, which was length of ace. So we call length of CE, which calls length of E, which has E as an input, and the return to CE. In other words, it has the return call of this, the return address of this. And then finally, empty string has the return address of this. You have nowhere to go after your empty string. So what we have to do, so after that, we just simply pop off and return to this code that called us. And that will pop off, and that will pop off, and it will continue to pop off the stack. So the analogy for this is that we've got some employee on each level with the same set of instructions. The employee on the bottom level carries out the instructions, calls the employee on the next level up, and is put on hold. The employee on the next level does the instructions and calls the next level up, and they get put on hold, and so on until you get to the top level, right? You do a little bit until you get to the top level, and then once that's done, it begins to unwind. Basically, the top level employee, he's got such a simple job. He does that job, returns it to the person below him, who combines their answer, and returns it to the person who called him, who combines the answer and returns it to the person who called them, and so on and so forth. Right? So, right, we've drawn this out before. Basically, the length of ace, right, will return 1 plus length of CE, which will call 1 plus the length of E, which will return 1 plus the length of nothing, which returns 0. So 1 plus 0, which returns 1, So 1 plus 1 returns 2, and 1 plus 2 returns 3. So that's how we know what the length of ace is. But this runtime stack is how Java does it.